Okay, so we got a file to download for today, books.xlsm. Today we are looking at making decisions in our code. The course textbook refers to this as conditional branching. We're talking mainly about the variations on the if statement. We're also going to look at the select statement today, and hopefully we're going to do it with some examples that will have some general utility and specifically for some of the projects that we have coming up. So let's go ahead and get that workbook downloaded. And take a look at the data that we've got here. So this is just some data that I scraped off of a web page somewhere. It's got some ISBN and then the title of that ISBN and the author. So it turns out that it's a pretty common thing nowadays to get text that you've got to work through that's got some kind of HTML markup built into it. So here, by the way, do you know what tag this is? This I tag, what does that tag do? Anyone know? Like if I was to render this in HTML, that's making it italics, which makes sense because that's the title of a book. It should be rendered in italics, and that's what that is. So ultimately, we're going to do a couple of examples today. One is going to be to look at this ISBN and strip out everything from it that's non-numeric. Kind of look at that and say, you know, we've got hyphens in there. Forget the hyphens. We only want the numbers. Have you ever seen ISBNs written in any other format besides this with hyphens between the blocks of numbers? Yeah, sometimes different publishers do it different ways. Sometimes they use dots, sometimes they use spaces, sometimes they run it all together. I've even seen them with slashes in between. So the number is standard, and these little blocks of numbers are different too. Like this first part actually says this is a book. This next one I think identifies who the publisher is, and there's kind of different components that make up that international standard book number. But let's go ahead and take a look at building some tools to work with that. So our first one is we're gonna create a procedure. Actually, we'll create a function. We've got a whole day where we're talking about functions. It's coming up pretty soon, so I'm going to kind of preview this topic to you today. Well, let's go ahead and insert a module. So I'm going to come over here to my code, insert module, and I'm ready to. Now, almost, I think every other time we've done this, we start off by saying sub. I am recording. Thank you so much for asking. So sub, then I give it a name. Let's just make a sub procedure here called numbers only. Numbers only. And so inside this sub procedure, we could write, logic that does whatever we want it to do. Maybe it would work with whatever data is in the active cell and then goes and does something with it. But now, instead of making a sub procedure, I'm going to make something called a function procedure. A function procedure is exactly the same as a sub procedure, except that when the function is done running, it sends a value back from whence it was called. So I'm going to change this from sub. I'll see that. You may not have totally caught that. I'm going to explain that here in just a minute. I'm going to change the word sub to function. And you'll notice that when I leave the line, it changes my end clause to end function as well. So far, this is going to do exactly the same thing. Now, what I'd like this thing to do is I would like it to send a value back to where it was called from. And the way that we send a value back in VBA, I don't know any other language that does it this way. Almost every other language, it'll be like, I want to return a value. So there's a statement called return, R-E-T-U-R-N. That's Python, that's JavaScript, that's Java, that's C, that's C++, that's C#. It's every other language I know. If I wanted to return 22, it would just send back the value 22. But in VBA, I actually set the name. This is weird. I set the name of the function equal to a value somewhere inside the function. And that is going to make it return that value. So right now, this is not a very interesting function. It just always returns the value 22. I could call it from the immediate window. I could say print numbers only. And it would print 22. It will return whatever value I've set it equal to whatever place it was called from, right? That will have exactly the same effect as print 22. Those look exactly the same because when I print numbers only, the VBA interpreter goes, numbers only? What the heck is numbers only? It's not any built-in statement that I know, and it's not any variable. I can't figure, oh, it's a function. And it says, I got to figure out what this thing evaluates to. And so it goes and runs the code that's defined by this function, and then it returns whatever it says to return. Now, of course, we can have all kinds of complex logic that will return something different based on whatever it is. But the other thing I want to point out is that I can actually use these functions that I've created, like over here, right in my workbook as well. So when I say like to wherever it's called from, really wherever it's called from. If I wanted to put a formula in here, I would say equals, and then I could say, you know, sum, or I could say average, or I could say numbers only. And I want opening and closing parentheses. And then it just runs that code over there in VBA and returns its value right here into the cell of Excel as well. I could have another sub procedure over here that calls that function, you know, and just kind of does the same thing I did in the immediate window. And that will then do the same thing. A sub junk, print numbers only. I gotta say debug.print here. And so that just, you know, prints that up to the immediate window. So functions are neat because they can have, do all the same stuff that sub procedures do. Well, almost all the same thing that sub procedures do. In a function, you can't modify a worksheet. Things could go crazy if you had functions modifying worksheets that were then causing other things to go. And so functions are not allowed to modify the state of anything, but they can read from worksheets and then they can send a value back. All right, but what I'd like to do now is I would like to give this function something to work on. I want to give it something to chew on. And so because I'm going to be doing something with whatever this function sends back, I've got to put the argument that I'm sending to it inside of parentheses. And I'm just going to pass it one of these ISBN numbers. Now, if I just try to pass it like this, that's syntax, that's actually valid syntax, that's legal to do. But what is VBA going to do with this number? What is it going to do with this expression? Yeah, it's going to look at that. It's going to say subtraction. That's going to be some pretty big negative number. Well, not pretty big. It'll be, you know, thousands, because I'm taking 989. I'm subtracting 28 off of it. I'm subtracting 600 and then 6,000 off of it. So, oh, print numbers only. Oh, I have to give it. Let me do this. Let me just print that expression first. But what if I actually want it? What if I actually wanted to print that particular sequence of characters? What do I have to do? Yeah, put it in quotes. Yeah, don't try to figure this out. Just that's what I want you to print. And so that's what I want to send down. So even though in the cell, it doesn't have to have quotes around it, over here for this debugging, got to put quotes around it so it doesn't try to do the math on that number. Now, I'm going to try to now send this value down to have my function work on that number. And so I've got to put some variable here to be able to collect that number. And I'm just going to call this data, and I'll take that in as a string. So now, instead of returning 22, I'm going to return data. This is almost as boring as just returning a constant, because I'm saying whatever you pass in, I'm going to send it back. So that should print that same 989 whatever number. Okay, so now we've got the building blocks in place. We're ready to add some logic to say I only want to keep the values that are in this string that are numeric. So I only want to keep those ones that are numeric. Okay, are we ready to do it? I want to make sure you're to this point. You got this skeleton in place. Question. So if you have argument not optional, that means you've got an argument down here defined, a parameter here, but you're not passing it a value. So make sure that when you're calling it, you're giving it a value to send down here. Yeah, it's possible that I could make this argument optional, and then I would be allowed to call it without passing it a value at all. We're not going to do that today. That fix it? Did that fix it for you? Or okay, good. Okay, other questions? All right. So what I think I'm going to need to do, kind of thinking about this from a high level, I want to look at every single character in this string And I want to decide if it's a number. If it is, I want to include it. I want to somehow queue it up, get it ready to send back. And if it's not a number, I want to ignore it. That's the thing. So I'm going to start off by just being able to go look at each one of these characters individually. So I'm going to declare 3 variables to kind of help me do this. So let me dim one called one char. It'll be one character as a string. I'm going to show you this next part just because it's kind of interesting, but it's not something that you need to learn for the midterm or anything. Remember, we talked about the string data type, that it's a variable length data type, which means how much memory gets used for it depends on what you put into it. Plus, there's 4 bytes of overhead in this data type to keep track of how long the data are. I mean, how long is your string? 4 bytes tells us how long the string is, and then there's 1 byte per character in that string. Now, I can get rid of that overhead if I say, listen, this thing is always going to be a particular length. And since this is only going to be 1 character, it seems like a lot of wasted memory to say, I'm going to use 4 bytes to keep track of how long this character is. I can, when I'm declaring a string, I can say how long it's allowed to be. And so by saying for this data type, it's kind of a strange syntax too, but dim this variable as a string *1, that says, this variable is always going to be 1 character. It's no longer variable length. It has to take exactly 1 character, which means I don't have to use the overhead, the 4 bytes of overhead to keep track of how long the string is. This example would work exactly the same if we didn't put that *1. It would just use a tiny bit more memory. It would use 4 bytes more memory, big deal. By the way, coming up pretty soon, I'm going to show you how to declare thousands or tens of thousands of variables with a single statement. And then it can get to be a big deal if you're using the right data type and you're trimming, how much memory you're using. Okay, I'm also going to declare x as an integer, and I'm going to declare temp as a string. So x, I'm going to use x to control a for loop because I'm going to want to go through, iterate for every character in this string. And so this variable is going to help keep track of that. And this temp variable, I'm going to use to help keep track of what I'm going to send back. So I've got data that's being passed in. I'm going to look at those 1 character at a time, and then I'm going to use temp to keep track of the ones that I want to keep. Okay, so now I'll go ahead and make a for loop. For x equals 1, 2. I think we've got a whole class coming up on manipulating like built-in functions. So we're going to preview a couple of those today. One of them is called len. And so the function len takes a string and it will just tell you how many characters are in that string. And so I can give it this. It says that's 17 characters in that, right? If I put, make it a little bit longer, it'll be 22 characters. So I want x to start at 1, and I want it to keep executing as long as it is less than or equal to whatever number I put here, right? If I put 100 there, it would iterate 100 times. But if I put the length of data, it will be however it'll iterate once for every character in the string, however long that string is. So now let's do this. 1 char is equal to, here's another kind of preview of some of these string functions we'll be talking about in more detail. I want to take something out of the middle of some string. I want to look at data. I want to start at let's just preview this one again as well. Let me do mid, looking at this string. I want to look at the 3rd character, starting at the 3rd character, and I want to extract out 1 character. So what that's going to do is it's going to say, all right, I'm looking at this string right here. I want to find the 1, 2, 3rd character. And I'm going to bring back 1 character. That's just going to bring back 9. If I said I want to bring back 3 characters, it'll start the 3rd character and bring back 3. But what I want to do is I want to look at data, whatever gets passed in. I want to look at the xth character, and I want to bring back 1 character. So the first time through this loop, x is going to be 1. So this expression will look at whatever data is passed in at the 1st character and bring back 1 character. So 1 char, if I run this one, will be 9 the first time through. The next time through this loop, x will go up by 1, and so it'll look at the mid of this string, looking at starting at the second character and taking 1. And so that's just going to look and evaluate those characters one at a time. Let me just go ahead and say debug.print 1 char. And let me go ahead and print X and 1 char. All right, and I'm going to go ahead and run this. Now, there's kind of 2 print operations happening here. I am saying print whatever this function evaluates to, but along the way, while this function is trying to evaluate, it's also going to print some stuff up to the immediate window. And so when I hit enter on this line, it should print every single one of these characters and then print the whole thing at the end, because this is printing 1 character at a time. And then this one is saying print whatever we return. At the moment, we're returning exactly what gets passed in. So first time through the loop, it printed 1, printed X, which was 1, and then the first character to the second character and so forth. How comfortable are you with what we have so far? 5, 5, 5, 5, 5, 5, 5. Excellent. Okay, so now what I'm going to do is I want to accumulate the values I'm going to return. So I'm going to say temp is going to take on some new value. Okay, so temp is a string variable. All of these variables start with a default value. In many other computer programming languages, when you declare a variable, it just says, oh, great, here's the memory that you can store that variable. That memory already has a bunch of 1s and 0s in it. And so what's going to be in that variable when you first declare it? Whatever those 1s and 0s happen to mean now that we're thinking about it in that particular data type. But in VBA, it says that's really dangerous. We don't know what's there, and it could give you something strange. And so VBA initializes all of its variables to a default value. What is the initial value for any numeric data type? So integer, long, single, double, currency. 0 is the default value. The default value for strings is a 0-length string. It's an empty string. And so this thing starts off as a string with no characters in it. So what I'm going to do is that every time I go through this, I'm going to say temp is going to equal a new value. What is it going to be? What it used to be, concatenated on with 1 character. And so now I'm going to return temp. Let's think about how this executes. First time through, when this gets declared, temp is a 0-length string. The first time we hit this, we're saying, great, temp's taking on a new value. What is it going to be? Its old value, 0-length string, concatenated on with my character. So it's going to be 9. The next time through the loop, temp is going to be 9. So its new value is going to be its current value, 9, concatenated on with the next one, which is an 8. And so this is a weird way of actually making temp equal exactly the same thing as data. We're going to get more complex here, but now I'm returning the value temp, so this should still execute the same way. It should print off all those numbers and then print off the whole thing. Now I think I've got the structure in place that I'm ready to say, I don't want to put every character in there. I only want to accumulate the characters that are actually numeric, that are numeric characters. Good news. There's a function for that built into Excel called isNumeric, built into VBA. So isNumeric, it takes a string like 5, and it tries to say, can I look at that and figure out what number that would be if I thought about it as a number? And if it can convert it to a number, it'll just return true. Yeah, that's a number. If it's not a number, it'll return false. Now, it's not so smart as this. Is that a number? Yeah, but it's not the kind of number it's looking for, right? It's actually looking for a numeric symbol. Now, how about this? How about 4.4? You think that's a number? Yeah, that's a number. How about 0.4? That's a number. How about point? Not a number. Okay, so it's going to look at whatever you give it, and it's just going to return yes or no if it's a string representation of a number. Actually, oddly enough, if you give it a number, it's going to convert that into a string and then check to see if it can convert it back to a number. So that's still going to be true. But it does, strangely enough, it converts it to a string before it evaluates it. Okay. So now, introduction to the if statement. The if statement, it has this format. If, we'll put something between the if and the then, And then we're going to have an end if. Okay, this is like, I'm sorry, end if. This is like the simple form of the if statement. Whatever goes between the if and the then has to be something that can be evaluated to true or false. So what I'm going to do is, well, good news, is numeric evaluates to true or false. So I'm going to say if is numeric 1 char, then that's when I want to build up that temporary variable. So now, the thing to realize here is that whatever is between the if and the then has to evaluate to true or false. The isNumeric function itself returns true or false. So this will have to figure out, it'll have to go run this function built into VBA, isNumeric, it'll return true or false. And if what's between the if and the then is true, then this line executes. If it isn't, it skips to the end if and moves on. By the way, we could have any number of statements inside between the if and the end if that we want. So we can have a whole block of coding. Okay, this actually should do exactly what I'm after now. We'll see some other variations. Okay, so I'm gonna run this again. It's still got this debug print is still here in the middle. So it's still gonna print everything off. But now it should just return only the numeric parts of that. Pretty good. You get rid of the debug.print now because I think we've kind of demonstrated what we're trying to do with that. And let's just, see what it returns. Now, it's not just looking for hyphens, of course, it's looking for anything that's non-numeric. So I could put in there, hello, world. And that won't change what it returns because none of that was numeric. Well, here's a couple of things, here's a couple other things I could do. Let's just look at a different variation here. So a really common variation is the else clause. Else says, hey, if this is true, do whatever is between the then and the else. And then drop to the end if and you're done. But if this evaluates to false, then jump to the else and then execute whatever's between the else and the end if. So I'm going to do this. So here I'm going to take numbers, whatever is a number, and I'm going to convert it into a space. So I'm saying, listen, whatever is not a number will turn into a space. So here we're saying, listen, if it's a number, just include it. If it's not a number, so if isNumeric is false, then replace it with a space. So this will now give me 989, a bunch of spaces, and then the rest of my numbers. So, and it may be helpful to kind of look at this one line at a time. So let me move the debug.print up here so we can see it happening. And sorry, I want that inside the loop. And I'm going to put a stop right here. Remember, stop is just going to halt my execution of my code, but leave the function in memory, leave all my variables in memory, and let me kind of poke around and see what's going on. So now when I run this, I'll do like F8 to step through this. It's going to print that first character, is number 9. Is that numeric? Yeah, so we'll come in here and come up to the next one. F8. 2, 8, that's numeric, so just come into the first part. Next time through, it's the 9, that's numeric. Now it's the H, and isNumeric on H is going to be false, and so you'll see that we're going to jump straight to the else clause, execute that, and run through. So it's going through very methodically, very systematically, and deciding what should be included, what shouldn't be included. And so that's giving me this result. Any questions here? one last variation that we're going to look at with this example, and that is in the event, such as I have here, that there's only a single statement that's going to be executed conditionally, there's like a simpler format of this. And that is, I don't need, and I don't care about doing something when it's false. I only want to execute a single statement when my expression is true. Then I can do it just like this. Instead of having an end if, I put the conditional statement on the same line with the then. And now this is like, hey, this is just one statement. We'll just put it all on one line. No end if is required. No end if is allowed. So I'm doing a one-line conditional statement. It just goes like this, and there's no end if. Back in the early days of BASIC, like in the 1970s when BASIC was invented, this was the only form of the if statement. And if you want to do 2 lines, you'd just repeat the if statement with the same condition twice, and it would execute those 2 lines based on the condition. By the way, Microsoft is kind of famous today for like buying other like existing code and then like sometimes improving it, sometimes making it worse, but that's what they do. Like did Microsoft say we should have a word processor? Let's write a word processor. No, there was an existing word processor. They bought it and they called it Microsoft Word. Did they write Excel from scratch? No, there was an existing product out there. They bought it and they called it Excel and they took on development. Like the one thing that I know of that Microsoft actually wrote up from scratch, that Bill Gates himself wrote, was a BASIC interpreter. I mean, it was like the fundamental thing of what we're doing here in VBA. That's what Bill Gates initially wrote when he was starting Microsoft as a company. I don't know. That will not be on the midterm in case you're wondering, but I thought that might be interesting. Okay, so this should still now work exactly the same. And give myself a little more space here. I did not mean to have my debug.print in there still. And so that is just what I'm after. And so now I'm going to just go ahead and bring this in, and maybe I'll insert a column after column A here, and then just put the call to that function here. So this is called numbers only. Kind of nice that like even Excel knows that's a function you could choose now. It gives me that choice. I don't know how to actually choose that choice. Tab, I guess. And now instead of hard coding the value that I'm going to put in here, I just point at the value I want it to operate on. And then that's going to now do that in the worksheet for me. We're going to need this function this function that we wrote today. We're going to need this when it comes time to us actually writing an algorithm to look at that ISBN number and be able to tell if it's well formed or not. So that's coming up here pretty soon. In fact, how soon is it coming up? Oh, it's not next Monday, it's next Wednesday. So we're going to write a function in VBA that could look at an ISBN number and return true or false based on whether it's a well-formed ISBN number or not. Okay, any questions on the if statement that we've seen so far? We've got some more work to do on it. Yes?
If I change my macro code, what do I do to tell it to update the values?
Oh, yes. What if the question is, if I change this, what do I have to do to make this update? And the answer is just like come in here and like edit it and hit enter again, and that'll cause it to recalculate. In fact, let's do this. Let me go ahead and have it just return instead of 1 character for right now. I'm just going to have it return a dot. So it'll put the number of dots that we have that are actually numbers here. And I'm going to undo that, but that should be valid. So you'll notice it didn't. I made that change in the code, but didn't update this. I'm going to just change this first one, and that'll cause them all to update. And I'm going to put that back the way I want it, and then come here, edit that again, and that'll update it. Okay, there's a question in the back. That was the same question? Oh, I didn't really answer it, but okay. Okay, let's now look at another function. I think the next one that I want to do, let's look over here. I'd like to make a function that will look at this data and it will just get rid of anything that's in tags. This is going to be a little more complex, but I want to get rid of these tags. The rest of the data that's not inside the tag, I want to keep. So in other words, I want to keep the title of the book, but I don't want the I that's inside of these tags, just something to get rid of the tags. So let's make another function here called strip tags. And we'll, in fact, rather than build that again from scratch, we're going to need a lot of the same infrastructure that we had for this one. So I'm just going to start off by copying my numbers only function. I'll paste the whole thing, and then I will rename it to strip tags. So same thing, we're going to pass data in. We're going to still look at our characters one at a time. So let me just get rid of everything besides the one char in the loop. I got to now change the name of the function, what I'm returning. So instead of returning numbers only, I'm going to return strip tags because that's the name of the function. Ooh, somebody give me an algorithm. Talk to me. How am I going to be able to look at this character by character and be able to know whether I should be including, when I'm doing numbers only, I can look at each individual character individually and just say it's either in or it's out. Oh boy. But now how do I know, looking at a particular character, how do I know if it's in or it's out? Yeah. Ah, okay. So what you're saying, logically, you're saying, listen, you've got these things in the brackets, anything like inside the brackets is okay. And if I know that I'm dealing with the I bracket, like if I know that if I'm just trying to get rid of my italics tags, then I can actually look for I and slash R, you know, in the tag brackets and the greater than, less than symbols. I can look for I and say that's where I'm starting. Slash I, that's where I'm ending. And then I could, like, you know, do some kind of that mid function that we could use to take something out of the middle of the string and bring it back. And I think that worked really well if I knew I was looking for italics tags. But I want to say I don't care what the tags are. Like maybe if it's a link tag, like this is an anchor tag, A and slash A, I want to get rid of that as well. So like A, what would this look like? This would look like ahref equals https://google.com. Right, that's what a link tag would look like. I want to get rid of this kind of tags as well. So I don't have the luxury of knowing the tag I'm looking for. I'm saying, listen, if it's text that's inside angle brackets, ignore it. If it's not inside angle brackets, don't ignore it. So, you know, even though this one is natural pamplemousse, what is that? Anyone know what a pamplemousse is? Oh, really? Did you serve your mission in France? Excellent. Phoebe, I guess Phoebe did too, or something. So I want to keep the title of the book. I want to keep the author of the book, but the tag is going to come off. So other thoughts? Yeah. Ah, okay, I like it. So what you're saying is, let's declare another variable. Maybe I'll call it valid char. If this is going to be a true or false variable, what's the data type going to be? Boolean. Now, every data type has a default value. So at this point in my code, valid char would have a value. It would either be true or false. Which one do you think is the default value? False is the default value, but I think I want to assume that it's true. So let's go ahead and give it, let's start off with it being true. So let's say valid, V-A-L-I-D, valid char equals true. Okay, so I still want to loop across and look at every single character. I'm still going to pull one character at a time for evaluation. So I've got my one chair there. But now we're saying this. What we're going to say is if one char is equal to and opening bracket character, then we're going to do something. What are we going to do? Well, if I'm coming along here and I see an open character, an open tag, then I basically want to say everything else is a valid, everything now is an invalid character until I get to the closing one, and then everything's going to be a valid character. So opening tag character should turn just like turn off and say, hey, start now ignoring all characters until I see a closing tag, and then start paying attention to them again. So if that's the case, I'm going to set one char equal to, I'm sorry, not one char, valid char equal to false. Now, I'm going to now put in a new clause we haven't seen before. Else, E-L-S-E, E-L-S-E, if, one word, else if. Now here I can put another condition. One char is equal to a closing tag. Then we'll do something else. Valid char is going to be true. I can still put an else clause that executes if none of my other conditions have happened. And what will I do in that case? Here now, I will say my temp equals what it used to be concatenated with my one char. Okay, this is a little bit complex. Let's think about it. So this now says, look at this condition. If this condition is true, then we execute this. We start executing whatever is in this block until we hit else if, or else, or end if. And once I hit any of those, I'm done executing code in this block. Get me out of here. But if this is false, then we skip by this code and drop to the next else if. And we check to see if this one is true. If that one's true, we execute until we get to the else or an else if or an end if, whichever one we find. And then we know we're done with the structure. These blocks are mutually exclusive. Once we have found a condition that's true, we start executing that code, and it doesn't matter what that code does. That code could change something to make it so that this condition is also true, but it never even checks the condition. Once it finds one that's true, it executes that block, and it's done. So, important thing to realize is that these, when I see an else, an if structure, if, else if, and I could have any number of else ifs. I could have 1,000 else if clauses in here. Only one of those can ever execute. All the conditions could be true. Every single one could be true. In that case, only the first one would execute, because the first one it finds it's true, it executes, and then it's done looking. The different code blocks are mutually exclusive. The only way the else clause executes is if we made it all the way down here, and none of them were true before it. By the way, could I leave the else clause out? Like, is this legal? Yeah, that's legal. You don't have to have an else clause. But if you do, it just says, hey, if we made it this far and nothing else has executed, then we're done. I mean, then execute this, because we got to do something. I think that's going to do it, right? Because if I think about coming through here, this is going to look at that first and go, valid char is false. And so we'll hit this one, and then we drop out. So we never even get a chance to consider this. We go look at the next character. What the next character is an A, we're looking at this one. The next character is an A, and so that's not true. That's not true. And so we're going to get to this. Oh. So in this case, this is only going to get rid of my tags. It's going to leave what's inside the tags there. Let's just run this and make sure that's what it does. And then we'll make some other adjustments. Go ahead and I'll just bring in this text here. It would work just fine with any of the italics tags as well. Oh, except these quotes are going to be a problem. By the way, here's what it's saying. Saying, all right, you want to do this? Great. You're giving me a string literal. So it says, great, that's part of the string. Don't have to pay attention to it. It gets to that quote right there, and it goes, oh, that's the end of the string. And then it gets to this and it says, I have no idea what you're talking about. It kind of goes like that. It doesn't know. So how am I going to put a quote inside of a quote terminated string? This is weird. You ready? I put two of them next to each other. And what it says is, quote, beginning of a string, great. Part of the string, not paying attention, part of the string. And it gets to that one and goes, end of the string, I think. Let me just check and see if the very next character is a quote. And if it is, it's not really the end of the string, it's just a quote in the string. And so it goes, oh, I get it. One, that's really just one quote in the string. And then it goes part of the string, 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 part of the string. Oh, I think that's the end of the string, but let me check and see if the next character is a quote. It goes, it's not. And so it goes, that's the end of the string. And then we get to this, and it would go, oh, we're trying to see if this is greater than. That's like valid VBA syntax. We're trying to see if that is greater than. Over here, it gets to this and it would be confused because that's really supposed to be inside the string as well. Double that one up. And then it goes part of the string, 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 part of the string. Good heavens, how long is this string? And it gets to this one and goes, I think this is the end of the string. So it peeks ahead and it goes, oh yeah, that was the end of the string. And then it sees the parenthesis and goes, oh, I was expecting a parenthesis here. Perfect, that should run just fine. Okay, so it looks like it did what I expected. It got rid of the open tag and the close tag, but now, if it's not one of those, it's just doing this. So what else do I have to do here? Go ahead. Ah, that's exactly where I'm headed, but I want to show another idea first. And that is, I want this statement here to be conditional based on whether valid char is true or false. So this is to point out that we can put if statements inside of other if statements. Like any valid VBA code that I could just write could go inside of an if block. So I'm going to put another if statement here. I'm just going to say if valid char, then temp equals, then accumulate the character. Go ahead.
Add another condition to make sure we don't print out the ending bracket.
I don't think so, but let's take a look. I mean, let's run this first, and then I'll explain to you why we don't have to do that. Okay, I'm going to run this. We're going to see what it does, and then we're going to talk about it. Okay, so that looks like it did just what I was after. Now, any of the text that was inside that bracket we don't get, but we do get the title, and we're getting the name of the author. Now, the reason that we don't have to say, are we, actually printing out the closed bracket, because you're right. Once I hit that closed bracket, that's going to set valid char to true. And so this condition is going to be true. Isn't it going to print the closed bracket? And the answer is no. Why doesn't it print the closed bracket? It's because once I've executed this, I can't execute the else. These blocks are mutually exclusive. And so once I've come into this one, I hit the else and I'm done. It never even looks at this statement. So coming into this says, yeah, we've changed it to true, but we're now no longer, this is no longer an option because each of these main level blocks are mutually exclusive. Now, the other thing that I want to examine here is this is a Boolean value. It is itself either true or false. And yet, just from having taught this enough times, I know you folks are much more comfortable with this expression here. If one char is equal to this string, then we'll do something here. And so we could do that the same pattern here. We could say if valid char equals true. This doesn't, well, if I have the space in there, it doesn't change what it does. This now is exactly the same as it was before. And yet, it's going to feel a little more comfortable because it reads a little more like English. If valid char equals true, then do this. We're going to set valid char to false or true based on here. But when we get to here, if valid char equals true, then do that. But realize the syntax here is anything between the if and the then has to evaluate to true or false. And a Boolean variable is itself true or false. And so this is like, this will evaluate to either true or false. So if it evaluates to true, it'll look like this. If true equals true. By the way, the statement true equals true is true. The statement false equals true is false. And so when I have a Boolean variable, it's always okay to put the true equals true on there, but it doesn't actually change what it does. Right? You could say if it equals false, and that would reverse it, then what it would do by itself. So just to poll and see if I'm still reading the audience correctly. If you prefer to see this with the extra equals true on it, raise your hand. Yeah. If you're saying, you know what, I'd rather see it without the extra true. Oh, really? There's a few of you out there. You're strange. Which one is more efficient? Yeah, without the equals true, it's like one less comparison. How much time is it going to save me? It's going to save me like a nanosecond. I mean, the amount of time it saves is totally irrelevant. Like having code that you understand better is way more valuable than saving a nanosecond on how fast this code runs. Is it a nanosecond? It's way less than a millisecond. I don't know if it's a nanosecond, but yeah, I don't know enough about it to know how many like operations it takes to make that comparison, but it's not many. I wonder how many what do we call them? Floating operations per second, flops, how many gigaflops this machine does. Anyway, it's not very long, really. Okay. Now, the actual suggestion was, well, just make that part of this same clause up here. Just make this into an else if. And that's even a little bit cleaner. The code is a little bit cleaner because nesting ifs, although the VBA interpreter can handle nesting ifs as many levels as you want, there might be a limit. If there's a limit, it's not less than 32. Like you could nest at least 32 deep and probably more. Like this is if, and then inside that you've got an if, and inside that you've got an if, and inside that you've got an if. But the human interpreter can handle 2 levels of nested ifs. As soon as you go to 3 levels of nested ifs, you should say to yourself, I am now walking in unknown territory, and there's quicksand everywhere. Because it turns out that your human processor just doesn't do 3 levels of nested ifs very well at all. And so you should say to yourself, I'm nesting 3 levels deep. This is dangerous. And once you go to nesting 4 levels deep, you should say, I should find a better way. I really should find a better way. And the chances are there are many better ways than what you're doing. You may not know them yet, but we're headed there. So just be aware that like the main place that like errors that make it into production in code, where they happen is in deeply nested ifs. And the reason is because with that many branches happening, it's really highly likely that the testing you've done on your code has never tested all the different possible branches that can happen. And so, I mean, it takes like really great skills to write like test code that would test every single possible combination. If you're nested, 4 levels, it's, because it's like, it's exponential, like the number of possibilities that grows. So that on top of the fact that your brain doesn't handle nested ifs very well, that's where errors happen. Okay, but this now is a pretty useful function, right? So I could come in here and in column C or column D, I'm just going to go ahead and run this one. So this equals strip tags and tab. I'll pull this value in. And now I've got that same data without the tags on it. Delightful. Okay, questions? How comfortable are you with the if, else if, else if, else if, else if, else structure? 5, 4, 5, 4, mostly 5s and few 4s. Okay. For this next example, I actually tried to get this next part of the example into the file that we're downloading just before class. And I think I just forgot to upload it. So what I want you to do is come back to the blog, and I've given you a formula just at the bottom of the text. I've given you a formula that I want you to bring in and paste into the next cell over. Oh, it looks like I'm assuming that we've got the base data. So it's not, it's going to be C1 that we're looking at. So I'm going to go ahead and paste that formula here in column E. And I'm going to change it from B1 to C1. And it's going to give me a more complex, a slightly more complex version of what was there. Again, this is kind of similar to data that you might import, data that you've kind of pulled off of a web page. By the way, we're going to see kind of in this class, part of what we'll do is, see how to go and pull the raw HTML off of a web page, like to be able to log into a password protected website, navigate onto a particular part of that website and pull the data in, like the raw HTML, to be able to kind of have full power over it. And so you might find yourself dealing with text like this. There are a couple of characteristics now that we've added in complexity compared to what we had before. In fact, I think just for clarity's sake, I'm now going to copy this whole block that I have here, and I'm going to do a paste values over it. So it's not a formula, it'll just be raw data. It would work, everything I'm doing, it would work as a formula as well. But I just want to make sure you realize this has nothing to do with the formula part of this. It's just the data. I'm going to go ahead and I'm going to copy whatever I have here in E1, and I'm just going to bring it into Notepad so you can see something about it. Okay, so I just did a copy and paste into Notepad, and things look a little bit different when I paste in. There are two significant differences here. What are they? The first one is that there's a carriage return character built into this code. Oh boy, when I say carriage return character, I'm guessing you don't know what I'm talking about. When I say carriage return character, show me how well you understand that. 0 to 5. 0, 4, 4, 4, 0, 0, 0. You either understand it or there's a 1, 1. I've heard of it before, but I'm not sure what it is. Okay, let's take a quick look at that. Oh, I think we did talk about it. We talked about the background for this. I don't think we got to the carriage return character. So remember that the way that ultimately everything has to get stored as a number. Like when we store something in memory on disk, it's got to be stored as a number. Specifically, it's got to be stored as a 1 or a 0. So we can say, well, we can convert everything into binary, and then we can convert that to base 10. So we can think of it as being stored as a number. But then how do we get from a number to being a character like capital A? And the answer is there's an agreed upon mapping from numbers into specified characters, and that's called the ASCII code, ASCII, American AS, standard ASCII. Code for information interchange, I think is what it stands for. Let me just look for the ASCII code, ASCII table, ASCII table. This looks like it would be a fine one right here. It would be even finer if I could make it bigger. Open in a new tab. Okay. And so capital A is character number 65. So it stores 65 and then it says, this is a string, so that's going to be a capital A. And by the way, you can like get these characters like in Excel, like just coming and make a formula. Let me just come over here and make a formula here. There's a function called char, C-H-A-R, where I could give it the ASCII value 65 and it will go, oh, you mean A. Like, so like you could do this like directly in Excel. There's functions built in for this. And so, capital B is 66, lowercase b is 97, space is 32, but everything before 32, these are like codes to control, like what they were originally made for is like controlling printers. Like if I want to tell the printer to advance the paper, I send it character number, oh, this isn't the best one. This says device control here. I don't like this one. I don't like this. All of a sudden, I don't like this one anymore. This is better. So number 10 is a line feed. So if I wanted to tell it to advance the paper 1 line to start typing on the next line, I would send it character number 10, and it would say advance the paper. If I wanted to move the print head back to the beginning of the line, I would send it character number 13, carriage return. Right, so all of these are non-printable characters. Now, this is just the base 128 characters that are like standard everywhere. Let me see if we can find the extended ASCII table. In a new tab. So above the first 128, 0 to 127, now we've got these others. And these are not universally agreed upon about what these numbers, what character symbols these actually map to. How many of you ever been on a web page and you're looking at the data and you've got like a question mark where you know that's not really a question mark? Have you seen it somewhere out there? So that's happening because you're getting into, or even something like this, where you see like a U with like an accent mark on the top of it, and you go, that's not the character that really belongs, like something besides a question mark, some other kind. Yeah, so a few of you have seen this as well. That's where we've got characters that are beyond the standard 128, and whatever's rendering that is using a different mapping for these than others. And that is exactly what we have then happening here. That character right there, that dot, is an extended character. It's not one of the first 128 characters. And so that's interesting. By the way, we can get that by using the function code. That happens to be character number 149. That happens to be code 149. Oh, so not code. Code goes the other way. It's char 149. Code just reverses that. So if I do code and point it at that character, it'll tell me it's 149. But so this is kind of another kind of strange thing that you have to deal with from time to time, especially when you're pulling data off of web pages. Now, the other thing that's a little bit different here. So when I look here, all this happens on one line, and yet when I copy and paste it out, I get that carriage return character in here. So there's actually both of those characters are in there. Character number 13 and character number 10 are part of this string. That's why when I copy it out and paste it, this line breaks there. It's not wrapping. Right? We could scrunch this down. It's not wrapping because it got to the end of the screen. It actually has those non-printable characters. Any of those characters that are less than 32, they're control characters. They're non-printable. But that's something that you have to deal with in strings. And they're difficult to work with because you can't see them. They are non-visual characters. Okay. The other thing that's kind of interesting is that anytime you've got a carriage return in your data in Excel and you copy it out, it puts quotes around it. But that's beyond what we're dealing with here today. So that's the situation. So what I would like to do is I would like to be able to get rid of anything that's a non-printable character. And so I'm going to go ahead and make another, we'll make another function for this one. I got to find my VBA. Where did I go? VBA, where are you? There we go. And code. All right, so let's go ahead and make another function. I'm going to copy that numbers only one again, because that's a simple one. It's got me looking at each character individually. I'll come to the top. I'll paste that in, and I'm going to call this one, I'm going to call this super trim. Again, there is a function built in. Let me print something with a bunch of spaces on the front, high, and a bunch of spaces afterwards. And I'm going to concatenate onto that a capital X just so you can see this. So when I print that off, it says, great, you want to print a bunch of characters, and then an HI, and then a bunch of spaces, and then an X. There's a function built in called trim. And trim just takes off leading and trailing spaces, but it only does spaces. Well, what if I've got some of their non-printable characters in there? That doesn't do it. And so I'm going to call super trim is going to get rid, it's going to take out any of those non-printable characters. So again, I'm passing in data. I'm going to look at these one character at a time. I like all this exactly the same. But now, if I want to find out if it's less than a space. If it's a space, I'm going to say keep it for now. But if it's less than a space, I want you to get rid of it. And I want to say if it's greater than whatever character number 127 is, like if it's greater than that first standard one, I think I want to just replace those with a space. I'm saying if it's non-printable, get rid of it. If it's above what I know what to do with, just change it into a space. And we're going to look at a different syntax for doing that. First of all, what could I do that with? Like what structure of the ones we've seen so far, which one makes sense to do that with? Like if with a couple of else ifs in it, right? So if it's less than a space, do one thing. If it's greater than 127, do something else. Otherwise, it's a character that we keep. So in fact, then we've got time. Let's go ahead and write it that way first, and then we're going to convert it to the other structure that I want to show you. So we're going to say if, and why don't we go ahead and let's go ahead and work with, I think it'll be a little clearer if we're working with the numeric representation of these characters. So I can ask for character number 65. So in an Excel formula, it's char, C-H-A-R. But in VBA, it's just CHR that I can convert that number. Likewise, there's one called ASC that converts from, gives you the ASCII code of a string letter. So those two are mirror images of each other that convert back and forth like char and code do inside of an Excel formula. Okay, so I've got one char here, and so I'm just going to say if that ASCII code of one char is less than 32, 32 is a space, then we'll do something. Else if the ASCII code of one char is greater than 127, then we'll do something else. Otherwise, it's a keeper. We're going to change them differently if they're below, then we're going to change them if they're above. But if they're neither below nor above, then we are just going to say, we're just going to accumulate. We're just going to say, temp equals temp concatenated with one char. And while we're looking at this, let's say, listen, if it is lower, let's say temp is what it used to be concatenated with a lower bar, so an underscore character. So at this point, we want to be able to see what we've replaced, see that we've replaced something. And if it's greater than, let's replace it with a hyphen. Ultimately, we may want to change the symbols that we're using here, but this will let us see what we're dealing with. Okay, we haven't run this yet. Show me how you're following, how well you're following what I've done. 5, 5, 4, 4, 4, 5, 2. Okay. We're going to take a look at this in another variation here in just a minute. We'll go over a little bit more, but let's go ahead and pull one of these lines in here. Debug.print. And what did I call this one? Super trim. In fact, I think rather than try to pull it here, because it's going to bring in that line break is going to be a problem. So let's just do it this way. Let's just point it at cell E1. And the easiest way to do E1 is in square brackets E1. didn't like, oh, I missed my end if. Is that why you said 2? I don't understand how this works without an end if. And that's not numbers only now. It needs to be super trimmed, setting the return value to the name of the function. And let me put dot value on this just to make sure it's clear we're talking about the value. So now what I can see is that I replaced 2 characters that were in that block of non-printable characters smaller than a space. And then those are followed immediately by 2 characters that are those characters above the standard character. Wait, there's 2 of them there? That really looks like a character and then a space. Whoa. I'm going to copy that. I'm going to copy those. I'm going to copy these characters right here. Oop. I'm just going to put them in a cell by themselves just so I can play around with that for just a minute. Now, if I ask for the code of this, it will only actually give me the code of the first character in there. And so that's telling me the first character in there is that dot. It's character number 149. We saw that. But clearly, it appears that I'm replacing 2 other of these characters that are above that space. So let me get rid of the dot on the front, and that should tell me what that one is. That's number 160. That's 160. That character right there, can I highlight it? Yeah, that's character number 160. For all the world, that looks like a space. But it's character number 160. Do you know what character number 160 is? In the world of HTML, character number 160 is a non-breaking space. It's a space. It looks exactly like a space. But if you put 2 words separated by a non-breaking space, it doesn't allow those words to break. They've got to stay together with a space between them. So like if you're making your browser wider and narrower, those 2 will move together. And they'll never break on that space because, after all, it's a non-breaking space. And it is really common that when you import this data, you pull in non-breaking spaces, and it's maddening because you look at it and it looks like a space. And if you try to trim it, it won't go away because it's not a space. A space is character number 32. Non-breaking space in the world of web is 160. Cell doesn't do anything with 160. But now we can deal with 160 by getting rid of it, which is about what we're going to do. So, okay, but the whole reason that we're here, I mean, this will be a nice function to have, to be able to kind of get rid of non-printables and convert ones that are above the range. But I want to show you this same syntax with a different logic. Let me come back down here momentarily and look at strip tags for a moment. In strip tags, we are making different comparisons with the else if. We're saying, listen, if one, actually, no, this would be okay. Never mind. That's not probably the best example. Let's just go ahead and build it here. Here's another syntax that will do exactly the same thing, and it's a little simpler to read once you understand what it is. Let's take a look at it. It's called the select statement. So select, I'm just going to put the raw syntax in, and then we'll put the other needed stuff around it. Case and select, and then a few case statements in here. Case else. Okay. The select case statement is really similar to the if, else if, else if, else if, with one big difference. The big difference is with select case, it says, listen, we are looking at all of these comparisons are tying back to a single common expression. So we're going to do something different based on what the ASCII value of one char is. And so we're saying, listen, we are really interested in behaving differently based on what the ASCII value of one char is. And so I put that select case ask one char. I think that's right. Let me select. Oh, sorry, the case is on the wrong side. Case goes before this. There we go. So I say select case 1 char. And the truth is, I'm not really fond of the choice of words here. Just because case gets a little confusing because it's used here and it's used here. But I'm going to say case is less than 32. I will have another case if it's greater than 127. And I'll have the same blocks of code inside these. I'm just moving this code up here. Probably should not move it. I probably should copy it just so you can see the structure. These two blocks of code do exactly the same thing. The difference here, the fundamental difference, and why you choose one of these structures over the other, is that when I see select case, it's saying, what's driving the difference in the way this code branches? I'm always looking back to this one expression. Whereas in the else if structure, each one of these conditions is totally independent from each other. Now, in this case, I am looking at the same base expression, but this one could say, hey, if the ASCII character is less than 32, do one thing. If the value in range A1 is equal to something else, I mean, they really could be totally independent from each other. And in fact, in the situation where they are not independent, they're all looking back to the same one, this is the preferred syntax. Because when I look at this, it says, oh, this is always looking back to a common expression. So that's the select case statement. We'll go ahead and take that out, and that should run exactly the same way. I think I promised that we would be getting rid of what was below, but I guess we're not going to get there because we're out of time. That's conditional branching. Any questions? Little warning for the homework that's due tonight. You're going to be changing like an entire row's color based on what color the row currently has. So you're going to say, hey, what's the color on this row? If it's 4, make it 5. If it's 5, make it 12 or something like that. Although you can set the value of an entire row, you could say, the active cell dot entire row to get that whole row. When you're looking to see what the color of the current row is, you don't want to look at the entire row's color because that entire row could have up to 16,000 different colors on it because each cell can have a different color. So you want to look at the background color of the active cell, and based on what the background color of the active cell is, change the entire row of the active cell to that new color. If you've already started working on this, that made sense to you. If it didn't, the recording will make sense after you've started it. You can go back and look at it. All right, thanks for coming. Class dismissed. Thank you. What a nice crowd. I'll be here all week.